Smile!
Hi! So today we are going to do a DIY experiment on microfiltration versus ultrafiltration. Let's go!
For the first experiment, we are going to demonstrate the microfiltration technique. So, there are the material that we need. Here, we have a solid 1, solid 2, solid 3, membrane, receiving bottle, funnel, steering rod, and lastly, water. First of all, we put the solid 1 into the cup, followed by solid 2 and also solid 3. Then, add the water into the cup. Next step, we stir it until we get a raw material, or we can call it as feed. Then, put the membrane on top of the receiving water and pour the feed on top of the membrane and wait until our feed be separate. So from here, we can see in the receiving bottle, it contains of the solid 2 and also solid 3. Meanwhile, for solid 1, it will be left on top of the membrane.
Next, the second experiment is ultrafiltration demonstration. Here, we have the raw solution that contains solid 1, 2 and 3, same as the first experiment. Then we stir it. And this time, we switch the membrane that have a smaller pore size than the first one. So we pour the feed on top of the membrane and wait until our feed being separate. So from here, we can see that in the receiving bottle, it contains solid 2 only. Meanwhile, for the solid 1 and solid 3, it will be left on top of the membrane. And that's how the process of ultrafiltration.
So let me explain the principle behind the experiments. Actually, in membrane-based separation techniques, the filtration mode used is cross-flow filtration, not conventional filtration. So, the video that we will play later will explain on the cross-flow filtration. Are you ready to watch? We will now explore to the world of membrane. Our journey begins now. Fluid is filtrated in membrane and housing by cross-flow filtration mode, which is different as normal depth and filtration. The feed stream flow quickly across the membrane surface under pressure. The solvent and dissolved component of small molecule will pass through the membrane, which called permeation stream. The suspended solid like bacteria, oil, submicron particle, and dissolved components at high molecular weight will be rejected and flow from the other end. So let us take a look between microfiltration versus ultrafiltration, since we know that both of them separate by pressure driven, but microfiltration is a physical filtration process that separates microorganisms and suspended particles from the process. It has 0.1 to 10 microns pore sizes, and it has low separation skill because it only separates large molecules. Let us take a look at the simple process of microfiltration. So first, water containing particle bacteria and other impurities will be pumped into the microfiltration system, and then it passes through the filter with tiny pore and block larger particle and contaminants. Then the clean water will flow through the filter, leaving the impurities behind. Lastly, the trapped particles are periodically flushed out and cleaned to keep the filter working efficient. Next, we will take a look on ultrafiltration process, which is a low pressure process to remove the turbidity causing particles such as suspended solids, bacteria, colloidal matter, and protein. It is widely used in water treatment and the membrane in ultrafiltration, characterized by pore size and MWCO, which is the pore size range between 0.01 to 0.1 micron and the MWCO range between 1 to 1000 kDa. The transport of solute depends on pore sizes and interaction between feed components and membrane matrix. During ultrafiltration, the high molecular weight solute will retain in the retentate, while low molecular solute plus water will pass through the membrane in the permeate. So these are our references. And thank you so much for watching.